Today we are discussing the Ethernet. What is Ethernet and IEEE 802.3? So what is the IEEE standard covers? So it is physical layer and interfaces to the link layer. It is a physical layer and interfaces to the link layer. IEEE 802 IEEE 802 is the link layer standards. Is the link layer standard. What is history? In the history, DEC Intel Xerox came up with it and came it with it and submitted to the IEEE for the standardization. Some changes were made so Ethernet is not identical to IEEE 8023. IEEE 8023. What is differences between the Ethernet and 8023? There are some electrical and connector differences. Most equipment issues uses IEEE 802.3. There are a different. There is a difference in the header. DAX uses the type of 802.3. Uses length. Since the frame is limited in the size, the two coexist. Most people uses the DIX format. Most people uses the DIX formats. We are using for the history and the differences and what is it covers. So IEE and OS, IEE, LLC and MAC and physical. Here we are using the LIC means logical link control and MAC media access control and PHY is the physical layer physical. So PHY is the physicals we are using for this one. OSI layer 1 and layer 2 we are using. So Ethernet work standard back in 1973 by the by Bob Metallefs and the divide box from Xerox Palo Alto Research Center, Parax. He studied the Aloha network and the fixed in the mathematics. An experimental Ethernet implemented in 1975. Cooperative export between the digital Intel and Xerox produced Ethernet versions 1.0 and 1980. This is also becoming known as the Blue Book specification or DIX standards. Blue Book specifications or DIX standards. Ethernet version 2.0 adopted in 1982. The Ethernet was adopted with the modifications by the standards committees IEEE 802.3 and ANSI 8802 or 8803. Ethernet allows for only connectionless communications. Ethernet is connectionless communications. This is normal Ethernet operations. Normal Ethernet operations. This is the standard data to node D data. So node D. This is the address match of the packet destroyed. Address match destroyed. This is the address mismatch the packet discarded, and this is the address match packet processed. Address match process data is processed. So this is called the transmitted packet seen by all stations of the LAN. So it is the broadcast medium we are using for this one. So this is using the broadcast medium. And Ethernet collisions. So this is the diagram for the Ethernet collisions. Here we are using the collision. Collision it is the data transmission for C we are using for this one. So data is transferred from to C. This is the collision. So this is data transmission from A. Data transmission from A. So this is the collisions we are using for this one. What is CSMA? CSMA carries sense or multiple access dividing a booster with the collisions detection. Boosters with the collision detections we are using. So this is the bus cable we are using. So this is 51.2 microseconds. 51.2 microseconds. Many stations listen before talking, listen while talking. If collision, back off and try again we are using. Collision, back off, collision, back off and try again we are using for this one, carrier sense. This is the carrier sense we are using for the CSMA or CD. Carrier sense multi-axis devising in the booster with the collision detection. CD means collision detection, CSMA carrier sense or multiple access we are using this one. And CSMA or CD, a simple definition, a network station wishing to transmit with all packets with will transmit will first check if the cable plant to ensure that no other station is currently transmitting. The network station wishing to transmit will first check and cable plant to ensure that no other station is currently transmitting. The communications medium is one cable, therefore it does allow to the multiple stations access to it with all being able to transmit and receive on the same cable. So receive on the same cable. The communications medium is one cable, therefore it does allow the multiple stations to access with the beginning able to transmit and receive on the same cable. So we are using the multiple access we are using for this one. So error detection is the multi detection is the implemented throughput the use of the station's listing while it is transmitting its data. Error detection is implemented throughout the use of the station listening while it is transmitting its data. Two or more stations transmitting two or more stations transmitting causes a collision detection. Collision detection. Two or more stations transmitting causes a collision. Next one, a signal is transmitted to the network by the transmitting stations that is detected to the collision to ensure that all stations know of the collision know of the collisions. All stations know of the collisions. All stations will back off the random time of, of random time. So detection and the transmission is accomplished in microseconds. Collision and transmission is accomplished in microseconds. We are using. And frame or this is the frame or packet format. Frameable. This is the frame. SFD, DST, SRC type data pad FCS. So this is the sizes we are using for this one. Size octets. Size is octets we are using. In IEEE 802.3, the type field is used the length field. Addresses addresses are generally 3 octets. Vendor code 3 octets of device numbers. Octets are device numbers. Addresses are generally 3 octets. Vendor code 3 octets device numbers. So Ethernet addressing each each station recognizes the three classes addresses. These three classes addresses: own address, broadcast addresses, all ones, optimally one or more multicast addresses. Major reason for the broadcast is addresses discovery. Major reason broadcast is addresses is discovery. Multicast addresses are used for specialized link layer functions we are using for this one. So addressing is mostly three classes we are using of the addresses. One addresses, broadcast addresses, optimally one or more multicast addresses we are using. The major reason for the broadcast is addresses discovery, and multi-class addresses are used for specialized link layer functions we are using for this one. So Ethernet cable names. So name name Ethernet cable names we are using. Thick coaxial, thin coaxial, thick coaxial, thin coaxial, and unshielded pair, and fiber. So name is wire type. I wire type R is RG8 thick coaxial, and thin coaxial is RG58, and unshielded twisted pair 22 to 26 AWG, and fiber is 62.5 or 125 microns. IEEE name 10 basis 5, thin coaxial 10 basis 2, unshielded twisted pair 10 based 10 based, and fiber is 10 base F. And started number IEEE 802.3, and thin coaxial I3 802.3A, unshielded twisted pair లో IEEE 802.3I, fiber optic cable లో none of this. Other names thicknet, thinnet, and UTP we are using for this one. Ethernet coaxial names we are using for this one. This is the thin coaxial makeup. Jackets of PVC telephone and telephone used for the fire code regulations, and think press EMI and foil, think brit for EMI, thin foil bonded to insulation. This is the center coordinator of the plated solid copper constructors we are using for this one. And thin coaxial connections. This is the This is the black marks every 2.5 meters, and show the transmitters of the placements. It shows to the every 2.5 meters it shows to the transceiver placements we are using. This is the transceiver cable, and the transceiver. This is the transceiver. This is the transceiver cables we are using for this one. This is the 500 meters maximum cable run we are using for this one. This is the thick coaxial connections we are using for this one. And transceiver, transmitter or receivers, the AUI on one side, media on the other, used on all Ethernet networks, and is the device that allows the data to flow between the control card and the network. Detects errors detect errors on the bus cable, detects errors on the bus cable plant, and reports them to the station's control cards. For thick coaxial cable, the transceiver is external to the controller card and attacks directly to the thick coaxial cable via special cable is known as the transceiver cable. For thick coaxial cable, the transceiver is external to the controller card and attacks directly, and thin coaxial cable via the special cable is known as the transceiver cable. And Ethernet transceivers have the SQE functions we are using. that cables are controlled to determine the status of the transceivers. Usually has status indicators physically located on it to indicate the state of the transceiver, transmitting, receiving, transmitting, receiving, collision, and power we are using for the usually has the status of indicates the physically located on it to located of the state on the transceivers. It is used transmitting, receiving, and collisions and the power we are using for this one. And thin coaxial cable makeup. It is a jacket node of the PVC and are collision and the polythene films we are using thin fiber cop fiber. This is called the EMI braided of the this is called the EMI shielding, and this is called the polythene frame, and this is the thinned copper to the wire we are using. This is the jacket of PVT telephone Teflon. PVC or Teflon we are using for this one. Thin coaxial cable. Thin coaxial connections we are using. So this is the BNC connectors we are using for each cable end we are using. And the T connectors. This is called the T connectors. And direct connection to the cord we are using for this one. Direct connection to the cord to this one. This is the connections of the network atta- attachments, connection of the network attachments we are using for this ones we are using for BNC connector for each cable and we are using for this one. Thin coaxial connections we are using, and thin coaxial connections, this is the interface to the computer bus we are using for this one, and BNC connectors and AUI connectors here we are using. On board the transceiver logic we are using for this one, and the two connectors for the connection to the cable plant we are using for this ones we are using for this is. And UTP makeup. UTP is standardized by the IEEE 802.3 committee in October 19 of 1990, standardized by the EIA under the TIA 568A. UTP for lands is known as the classified as category 3, used for the lands up to 10 Mbps. Category 4, used for the lands up to 16 Mbps. We are using for UTP makeup, we are using for this one. Unshielded twisted pair, we are using, this is the unshielded twisted pair cable we are using for this one. So this is the repeater unit requirements we are using. So here RJ45 connectors of 8 pins and the 100 meters maximum cable to run straight through the pins 1, 2, 3 and 6 we are using for this one. This is unshielded twisted pair, at least 2 twisters per foot. At least 2 twisted for foot we are using for this one. This is the unshielded twisted pair connections we are using for this one. This is the connectors management. Uh, with the connection of writing into the common point of the network managers can be hub with the specialized software. Network management software resides not only the connection but on the external workstations and device the a PC or the for example for example the workstation can The workstation can query the connectors for information. Connectors also allow the control of individual ports. This software allows management of extract the information from each card that they instead in that repeater. You could query the hub for the statistics such as number of packets, the bytes, number of collisions, single and multiple, number of framing errors, number of time particular card de-instead itself from the network, ability to run on off any repeat card on the hub, and all the information is time and the date stamp we are using for this one. And Ethernet repeaters extended the network by the interconnecting multiple segments, extended the physical domain of the network, governed by the IEEE 802.3c working group of standards. This governance has election specifications of the repeaters. These physical connections of their repeaters viewed the vendor to vendor. So some repeaters contains the intelligence to detect the collisions per cable plant, de-insert themselves from a writing connector, submit network management information to a central controller. To a central controller we are using for this one. So this is the IEEE 802 efficiency warning options we are using slash utilized from 0 to 10. Status is great, 10 to 40 okay, 40 to 60 performance problems, look at it, 60 plus, so we are using for. So signals on utilizations are times we are using for efficiency we are using. So 0 to 10 unte great full status, and 10 to 40 unte okay, and 40 to 60 performance problems we have to implement it. 60 plus we are not using for this one. This is the topic we are discussing tomorrow. Next.